The use of local post-process volumes can be very useful, especially when animating filter values based on where the camera is set in the environment. The post-process volume component has very interesting properties that will allow us to achieve this effect. IsGlobal is a checkbox that enables the post-process volume to send values to the camera wherever its position is in the scene, and by unchecking it, the post-process volume becomes a local volume. Only when the camera enters its boundaries, it will be affected by its values. Blend distance makes gradual transition between volumes. Before editing it, make sure that Gizmos is selected to get a visual representation of what's going on in the scene. Select the post-process volume and press F to focus. When increasing the blend distance value, a box area around the post-process volume starts to grow. That is the blend distance. Set it to 1. And make sure that constrained proportions are enabled. Then set the scale to 5. When you enter the play mode and go towards the post-process volume, you'll notice a gradual transition as the camera gets closer to it. Reset the transform of the post-process volume. And also check IsGlobal again. Another way to blend effects is by using the weight value. While changing the value, you'll see the post effects fading in and out. Let's move on to work with multiple volumes in one scene. Copy and paste the post-process volume, then rename it to local volume. Move it to another place in the scene. In the Box Collider component, press Edit Collider. To increase its volume symmetrically, hold Alt, then use the left mouse button and change the position of the dots. In the post-process volume, uncheck IsGlobal, then set the blend distance to 1. Go to the Project tab, open the post-processing folder, copy and paste the global reference, then rename it to local volume. Drag and drop the post-process profile into the profile slot. Edit some values to be able to see the transition when testing. When testing the scene now, no difference is noticeable, and that's because the post-processing stack use a priority system so that volumes can stack on top of each other's. Set the priority to 1 to make the local volume render on top. Enter the play mode and test the scene. It's worth mentioning that volumes stack in an additive way. Effects that are not affected will be excluded. As an example, when removing unmodified effects from the local volume, the camera will still render these effects as they are modified by the global volume. Also, if the same effect is used by two volumes, in this case, the camera will blend the effect by its properties. If not all the properties are modified by the local volume, the camera will get those values from the global reference. This is it for the dynamic post-processing. We will be looking at how we can create advanced effects using the post-processing stack. First, we are going to create a night vision effect. Before starting, I just want to mention that it's very important to analyze how effects work in real world before translating them into filters in video games. There are two types of night vision: image enhancement and thermal imaging. We are interested in image enhancement, which is the green looking one. So how does this effect works in the first place? Night vision devices work in the invisible light spectrum, with parts near to infrared spectrum. Each device is equipped with image intensifying tubes, which are the heart of the device. The light is always present in nature, even in the darkest nights. coming from distant stars, moon, and partial reflections. That light is captured and focused from the night vision devices to the image intensifying tubes. The light enters in form of photons, then transform into electrons. The electrons are then amplified to a multi greater number through an electrical and chemical process. These electrons are then projected into a phosphor screen to change the amplified electrons back to visible light. So how can we recreate this in Unity? The trick is to make all of the colors in the scene diverge into a single color temperature to be able to produce the grayscale image, and we can do this using the white balance temperature in the color grading effect. But first, go to the post-process folder in the project tab and rename the local volume to night vision underscore IE for image enhancement. Make it global temporarily to immediately see the result. Go to the color grading effect and change the temperature for an extreme cold or warm value. This will shift all of the colors in the scene into a single color hue, but you can differentiate between them by their saturation. Now we need to make all of them grayscale, but not completely. Set the value of saturation to -75. Our final step is to use the hue shift to shift all of the rest non-grayscale colors to a green hue. You can play with the intensity of the colors to amplify the brightness of the scene. And to make the effect more realistic, we can add grain to give the image an organic look. You can also play with the vignette to make it more natural. And check is global, then test your scene to see the result. You can add as many local volumes as you want. As an example, we can add an underwater effect for this area. Copy and paste the night vision volume, then rename it to underwater volume. Make it fill this area as an example. Quick note, you can add as many colliders as you want to shape the volume to the area you're working on. Go to the Project tab, copy and paste the global reference, then rename it to underwater. Add it to the post-process profile, then check is global. Now we are ready to modify its properties. First, go to the color grading effect, then change the tone mapping to neutral, as it will make the colors feel softer. Moving on to the white balance, decrease the temperature, as it will make the image feel colder. Set it to -15. Then increase the tint to 40 to push it more. Now, we can use the color filter to sell the look of underwater volume. We can use the depth of field to make the vision limited to only few meters. We can achieve this by using shallow values. 3 for the focus distance, 2.8 for the aperture, and 65 for the focal length. Increase the intensity of the bloom and the chromatic aberration as lights glow more underwater. Also use the lens distortion to get the fisheye effect. Decrease the value to get a pincushion distortion. A value around -20 would be enough for this case. Adjust the vignette to make it harder when seeing the edges of screen. And check is global and enter the play mode and test your final scene. Before ending this lecture, I want to refer to a very important aspect of game development, which is aesthetics. I'm sure that we all know what graphics is, but what about aesthetics? Graphics simply means adding details. Aesthetics is what tells graphics how to display those details, and what is the context and reason for displaying them in that particular way. Aesthetics are the emotional context of the experience that connects the player to the game, which includes the story, music, mechanics, and also visuals. Graphics are important, but alone aren't the answer. Mirror's Edge is a game that perfectly establishes both realism and aesthetics in a way that creates an amazing atmosphere that immerses you in its world. Color palettes are carefully chosen, and the graphics looks really good. To conclude, graphics is a tool that exists to serve aesthetics. Better graphics allow for better look. Better aesthetics allows for better games.